Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to explain the pump performance curves. The pump performance parameters I have discussed already in the form of the flow rate, in the form of different efficiencies, overall, volumetric and mechanical efficiencies. And here, those different types of the pump performance are represented in the form of curves on the graph. And that I am going to discuss how the variation of these pump performance taking place. Those are represented in the form of curves on the graphs. Pump manufacturers specify pump performance characteristics in the form of graphs. Test data are obtained initially in the tabular form, then in graphical form for better visual interpretation. The graph below represents typical performance curves obtained for a 6-inch cube variable displacement pump operating at full displacement. The first graph gives overall and volumetric efficiency curves as a function of pump speed in terms of RPM for a pressure levels of 3000 and 5000 psi pressure. The second graph gives the curves of pump input horsepower HP and the pump outflow GPM as a function of pump speed for the same two pressure levels. Performance curves for the radial piston pump are presented in the graphs 3 to 5. Recall that this pump comes in three different sizes. The radial piston pump comes in the three different sizes. Those are as a PR4 24, as a 2.4 inch cube displacement, PR30 3.0 inch cube displacement, PR40 4.0 inch cube displacement. Now we'll take the first curve where the pump's speed is plotted against the efficiencies at 3000 and 5000 psi pressure. And first we'll take that is volumetric efficiency. The volumetric efficiency curves for the 3000 psi pressure, whereas initially it is low and gradually it will be increasing and that reaches a maximum and that level will be maintained. And volumetric efficiency at 5000 psi pressure, that will be lower than that of the 3000 psi pressure initially, and it will be varies in the same manner of the 3000 psi pressure, and that will be increasing but somewhat lower than that of the 3000 psi pressure, and that is also varies in the same way and maintains constant later onwards at a higher speed. And by taking the overall efficiency of the pumps, the overall efficiency for the 3000 psi pressure, it initially it will be lower and it will be increases up to certain speed range, and later onwards it will start decreasing. It will be start decreasing, and here the variation will be there. Okay, increasing up to the certain level and decreasing will taking place for 3000 psi pressure. And for 5000 psi pressure, it will be somewhat lower. How it will be there volumetric efficiency like that, and that will be increases as the speed increases, and that will be reaches at the point where the 3000 psi pressure pump also reaches maximum, and later onwards it will not decreases drastically. The gradually it will again increases and reaches maximum at certain the speed higher than that of the 3000 psi. The 3000 psi pressure it will be reaches maximum at a lower speed compared to the 5000 psi pressure, and later onwards reaching the maximum, the decrease in the overall efficiency will be somewhat less compared to the 3000 psi pressure. That value we can observe here for both this 3000 psi pressure, the minimum will be around 85, less than 85, and maximum it will be reaching around 90. Okay, somewhat less than 90% of the overall efficiency. And for 5000 psi, the minimum efficiency will be around 80% and maximum that have reached about the 90% overall efficiency. Volumetric efficiency, if you take that one, here it will be more than 85%. The minimum value it will be there for the 5000 psi pressure, and that will reaches more than 95%. More than 95%. Okay, but it's somewhat lower than that of the 3000 psi. Here the lower value will be around 92.5, less than 92.5, and reaches the maximum about the maximum than that of the 5000 psi pressure, and that is very closer to the 100%. That is a 98% of the volumetric efficiency for the 3000 psi pressure we can get. Okay, this is the graph which shows the variation of these two efficiencies with the pump speed at two rated speeds, rated pressure, at the 3000 psi and the 5000 psi. Next, moving to the next, here pump input speed in terms of the RPM plotted against the pump input HP, the pump input power required in terms of the HP, pump output in terms of the GPM, grams per minute, the flow rate, it will be plotted. And again, we are going to consider the three rated pressures. Okay, first we'll take that is a pump HP. Okay, the pump out input power in terms of the HP in input power in terms of the HP at 3000 psi pressure, and its value will be around little above the 20 HP, 20 HP pressure to 20 HP power in input requirement, and it will be reaching around the more than 30, around 35 HP. More than 100. It will be reaching. It will be more than 140. 140 HP. It will be there. That will be reaching. And again, the for the 5000 psi HP input will be, the lower value will be around, okay, around 40, that will be there, and the maximum value will be more than 55. The maximum value reaching more than 55, more than, it will be 200. More than 200, its value will be more than 200 value we are going to get the pump input power. The pump input power of these two curves we can see the input power against these two, and the minimum value for the 3000 psi pressure and 5000 psi pressure at 500 pump input speed we are going to get. Okay, here we can see the at 500 speed RPM we are going to get the minimum value, and maximum value we are going to get at 3000 RPM speed. Then moving to the next, the pump output flow in terms of the GPM, that will be both for pressure ranges varying in the similar manner and almost closer value. 5000 psi pressure rating, the output flow is little below that of the 3000 psi pressure. We can see here these two curves. You can observe, and again the minimum value of the outflow we are going to have at 500 RPM speed, and the maximum we are going to get at the 3000 RPM speed, and both will be varying in the similar manner, and little lower and higher values are there. The little higher value for the 3000 psi pressure, the little higher flow rate will be there, and little lower flow rate is there for the 5000 psi pressure in terms of the GPM. This is the how the pump input speed and compared with that pump input HP and pump output flow rate in the form of graphs, how the variation is taking place, that we have discussed. Moving further, the radial, these three graphs are for the radial piston pump. In that radial piston pump, again that is, there are three types of the range of the flow rates are there. Those are the PR4, PR30 and PR40 are there. And the first graph 3, will give the pump speed in terms of the RPM versus the discharge flow GPM. Okay, that is the pump speed versus the discharge flow rate. This value of the discharge will be minimum at the minimum speed, the 0 at 0 speed. That both all for all the three what are the flow rate ranges are there. For all the three varies in the similar manner. But for the PR4 flow range, it will be lower value, and PR40 flow rating, it will be maximum. And for the PR24, it will be from the 0 to, it will varies at the more than 20 GPM. And for the PR30, it will be varies from the 0 to around 30, 0 to 30 GPM. And PR40, it will be varying from 0 to 40 GPM. As it is mentioned, PR24 and 30, 34, the flow ranges only, and that's why it should be get the 24, 30, and the 40. And this is how the variation it will be taking place. Similarly, here we will take that is the discharge pressure in terms of the PSI versus the discharge flow in terms of the GPM. Okay, here discharge pressure from the 0 to 2000, almost for all the three flow ratings, the discharge flow will be similar, the same. For the PR24, the flow rate will be lower, and PR40, it will be maximum, and the PR30, it will be in between. And this will be remain same, the flow rate will be remain same up to 2000 psi pressure. And here the RPM is maintained 2500. RPM is maintained 2500. And after the 2000 psi pressure, drastically decrease in the flow rate will be taking place, and that will be reaches minimum below the 2500 psi pressure. The flow rate will become a minimum because of this. The in the radial piston pump, it is not possible to deliver at more pressure, higher pressure. And here also, the for the 2000 psi, okay, up to the 2000 psi pressure only, the flow rates are compared. Okay, that is the reason. Okay, here for the higher pressure, due to the some reasons, it may be drastically decreases and reaches to the zero. And here the pressure we cannot maintain by using the radial piston pumps. Then the graph 5 in this, we are going to compare the pump speed in terms of the RPM against the efficiency. And here, first one will take the volumetric efficiency, and second one overall efficiency. And these two are very in the similar pattern. But the volumetric efficiency, which may be more than 90%, and it somewhat it will reaching the 95% maximum, and almost it will be reaching at 2500 RPM speed. Okay, lower value only. It will be reaching a lower value at 500 RPM, and that reaches the maximum at the 1500 RPM speed. Similarly, here the overall efficiency is also the lower value at 500 RPM, and that reaches the maximum, almost maximum, around the 1500 RPM, above the 1500 RPM. And that again reaches the lower value after the increasing the speed, it will reduces its value, and that will be at 2500, it will be around 80%, more than 80% overall efficiency we are going to get. And in these two cases, we are going to maintain always the pressure of 2000 psi pressure. Also, I have mentioned that one. The flow rate is drastically decreasing above the 2000 psi pressure. That is the reason we cannot use this radial piston pumps above this 2000 psi pressure. That is the reason here for these two cases also we have compared, and here also we have seen that one. Okay, above the 2000 psi pressure, what is happening? Like this, the variation of the different parameters are compared for the radial piston pumps also. Thus, there are three curves on two of the graphs, and two curves on one graph, what we have discussed. Observe the linear relationship between the discharge flow GPM and the pump speed in the first graph. Also note that discharge flow of these pumps is nearly constant over the broad pressure range. Almost constant, it will be not fluctuating, linear, and remains constant. Discharge flow is infinitely variable between the point of the inflection on the constant discharge portion of the curve and zero flow. Okay, that is that we have discussed that one. But for the particular range, it becomes a zero flow at after the certain range of the fresher range. And the volumetric efficiency and overall efficiency curves are based on the 2000 psi fresher, and the variation also we have already discussed. Thanks for watching Engineering Explained channel. Kindly subscribe, share and comment. Thank you once again.